Hello, assalamualaikum, and a very good day to everyone. In this video, we will look at the next topic, which is related to the Fourier series. What is Fourier series? So now, Fourier series is a mathematical way or mathematical tool to represent the non-trigonometric periodic function. So here is the example of non-trigonometric function. It is a square wave function. So Fourier series enable us to take this periodic function like this to non-trigonometric function and write it as an infinite sum of trigonometric function. And here is the general equation. The f of t simply represents the square wave function, and we can rewrite it as an infinite sum. Here is the infinite sum of either a cosine or a sine function added to a DC term or a constant term. So this is this represent the DC term, and this represent the AC term, which are dependent on the frequency, the radial frequency of the periodic function. So let's remember that the frequency of the function is 1 over period, and the radial frequency is 2 pi times the frequency, and it is equal to 2 pi divided by the period. So these trigonometric functions are dependent on this omega, or 2 pi over the period, the t period. So notice that also that n is simply the number here going from 1 to the infinity. Trigonometric representation of the square wave, we need to find the three coefficient, which is a sub naught, a sub n, and b sub n. Remember that a sub n and b sub n are the infinite number of constant from n is equal to 1 to infinity, but we typically will find some sort of representation of these two sets of constant. Here are the general equations to find a sub naught, the general equation to find a sub n, and also b sub n. For your exam, you will get the support sheet, A4 size support sheet that you can bring to the exam hall. So please make sure you have this in your support sheet. Now later we'll show you how to actually proceed with that and how to actually go and find this particular constant. So it comes down to, if you want to find the Fourier series of a step function like this, or in case of periodic function, I would say the square wave function, you need to find this value of this particular constant using all this formula, this general formula. And if you do that for a particular example, we will show you later how to actually accomplish that. You need to end up something that look like this. And in this topic, we will also first look at the introduction of Fourier series, and then we will look at the difference between the periodic and non-periodic function. I will make sure you get this basic understanding of the difference between periodic and non-periodic function, and also we will look at the trigonometric series, which I showed you earlier, which is f of x is equal to the arbitrary constant a naught plus the infinite summation of a sub n cos nwx plus b sub n sine nwx. And then also we will look at how to find the coefficient of a naught, a sub n, and b sub n, and also what is the value of w, how to get the value of w that you need to insert in this formula above, in this general equation above. So, and then we will look at the application of Fourier series for the plotting, decompose, and also obtain finite result of a series and solving non-homogeneous the ordinary differential equation. And we will look at the Fourier cosine series, sine series, and also even and odd function. We will look at how this shape of function, this even or odd function, can determine what is the trigonometric series that you can have at the end of this at the end of this topic. So Fourier series, as I mentioned earlier, we can use Fourier series to model any type of periodic function, like for example square function. So we can convert this square function to the trigonometric function using sine and cosine function. So it is a mathematical tool invented by this Joseph Fourier. It is just a sum of simple sine and cosine function. So he proved that any function that are periodic can be modeled with Fourier series. So please remember f(x) is equal to a naught plus the infinite summation of a n cos nwx and also b sub n sine nwx. So this is how you can find the value of a sub naught is equal to 1 over 2l. 1 over 2l, or l is the you can relate this L with the period. Okay, so L is the period divided by 2. Okay, and then an is equal to 1 over L, the integration from negative L to L fx cos nwx. Meanwhile b sub n is equal to 1 over L, integration from negative L to L fx cos nwx. Bn is equal to 1 over L, the integration from negative L to L fx sine nwx dx. And w, the angular frequency, is equal to 2 pi over p over period, or period, as I mentioned to you just now, is equal to period is equal to 2L. Period is equal to 2L. Okay, not L divided by 2. Period is equal to 2L. When we substitute P is equal to 2L, we can cancel 2. We can get pi. The angular frequency is equal to pi over L. Okay, so fx is a periodic function that you want to represent, and a naught, an, and bn are coefficients that determine the amplitude of each harmonic. And n represent the frequency of each harmonic, which it means that the higher the value of the higher value of n correspond to higher frequency. Okay, then the coefficient of a naught, an, and bn are calculated using integrals over one period of the function. So once you have this coefficient, you can reconstruct the original function here using the Fourier series formula. Okay, so for the periodic thing, you just for example imagine a simple function that represents a height of a bouncing ball over time. So if the ball bounces up and down in regular pattern, its height can be any given moment. Its height at any given moment will repeat after a certain amount of time. Okay, and also for example, if you play a song on repeat, okay, no matter where you start listening to the song, if you wait for a certain amount of time, you will hear the same part again. So this repeating pattern is what makes the function periodic. Okay, mathematically we can represent this periodicity as the f of t is equal to f in the bracket t plus np. So where t is time, p is the period, the time it takes for the pattern to repeat. You start and end the signal, and then you start again the signal. So this one cycle is called the period, and n is any whole numbers, just integer. N is just integer. And the difference between periodic and non-periodic function, periodic is the function where it repeats and the value at regular interval. The function repeats at regular interval, and the period does exist. In this periodic function, we have the period. We can find the period. We have starting point, and we have the point where the signal ended, the function ended. So in mathematical periodic function, ft is given by ft is equal to f in the bracket of t plus np. Okay. Meanwhile, non-periodic function is a function that does not repeat. Okay, it does not repeat. It value at regular interval, and there's no period exists. The period doesn't exist. We also call this as a periodic function. So in mathematics, a periodic function ft is given by ft is not equal to ft plus np. So whenever the question gives you the signal, the value of the signal, for example ft is equal to da da da, and also they give you ft is equal to ft plus np, so you know that that signal is actually repeating, and it repeats at regular intervals, so it is a periodic function. Okay, so from the picture here you can see this is a periodic function and this is non-periodic function. You can see the periodic function, you have the time where it starts here, okay, t, and then it repeat, and it starts from here and it ends here. So ft, and then here at this point is at the x-axis ft and t plus p, so p is the one period. So and then it repeat again, so the p become 2p, and if you repeat again it will become ft plus 3p, ft plus 4p. So this signal we call it as a periodic signal. Meanwhile, this signal is non-periodic signal, where it start here and it just end the signal is just ended. Okay, so this make sure you know what is the meaning of p, what is the meaning of L, what is the meaning of f, what is the meaning of w, and the mathematical representation of the periodic signal. So p, if you see, is a period, as I stated earlier, is a period of the signal of the one cycle. So we call it, the unit for period is the second, and then L is the half of the period. Okay, period divided by 2, or period is equal to 2L. Okay, so period divided by 2 is equal to L, and frequency in the unit of hertz is equal to 1 over p. F is equal to 1 over p, and the angular frequency W, which is very important in the this topic, is equal to 2 pi f, or because f is equal to 1 over p, we can have W is equal to 2 pi over p. So the mathematical representation of the periodic signal is ft is equal to ft plus np, where n is integer, can be any number. So example, we try to retrieve, the question asks you to retrieve the p period, half of the period, L, frequency and angular frequency from the following function, and write the mathematical representation of the periodic function. So it's given that the function is 5 sine of t. So the general formula for the sine wave is a sine wt. So where a is the amplitude, so the amplitude is 5, and the w, which is the angular frequency, is equal to 1. So 5 sine t has a is equal to 5 and w is equal to 1. So the frequency is equal to f is equal to w over 2 pi, or so because our w is 1, our angular frequency is 1, the frequency become 1 over 2 pi, and the period p is equal to 1 over f. So our period is 2 pi. Okay, and half of the period, which is L, is the period divided by 2. It will become pi. The mathematical representation of the periodic function ft is equal to ft plus 2 pi of n. So because our period is 2 pi, where 5 sine t is equal to 5 sine 2 pi n plus t, also known as period function with the period 2 pi second. So the Fourier series expansion is one of the most important part in this topic. You need to follow all these 5 steps for you to get the Fourier series expansion. So the first one, you need to retrieve all the information or important parameter from the periodic signal. It's like the same like what you just did just now. You try to find from the question, you try to get what is the value of period p, what is the value of the half of the period, what is the value of frequency, and what is the value of angular frequency. So the second step is you need to find all the coefficient of the Fourier series general formula. You need to find what is A naught, you need to find what is A sub n, you need to find what is B sub n using the formula given to you. And also the final step is to express the signal in the form of Fourier series, meaning that you already have the value of A naught, you already have the value of A sub n, you already know, you already have the value of B sub n. So substitute this coefficient into the general formula here. Okay, so here is some application of the Fourier series. You can read by yourself. It can be used to plot a periodic function. The second one, it can be used is to decompose a periodic function into multiple sinusoidal wave with various frequency. And then also the third application that we can give you is to obtain the finite result of a series. Okay, alright, now let us look at the Fourier sine and cosine series. Okay, the Fourier cosine series, if you know that you want to use the Fourier cosine series, okay, you know that you just need to find what is the value for the arbitrary constant A sub naught, and also the value, the coefficient of the A sub n. Okay, this is the case where the signal or the function is the even function. If the function is the sine function, the odd function, so just now is for Fourier cosine series, the signal is the even function. But for Fourier sine series, if the signal is odd function, if the function is odd, then you just need to find what is the value for the B sub n. Okay, so Fourier sine series fx is equal to the Fourier cosine series plus Fourier sine series just now. And now let us look at what is the difference between the odd and the even and odd function. Here, if you can see, this is the even function, this is the odd function. If you want to prove that by using mathematical definition of even function, you can know that f at the x-axis negative t, if it is here negative t, it will be equal to the value here, right? So the function, the value of the function at f at negative t is actually equal to the f of t. So maybe you try to rotate this signal on the y-axis, you can see that it is actually reflecting the signal on the before 0 and after 0 if you try to rotate it. Okay, for the odd function, okay, the mathematical definition for the odd function, the f of negative t, which is here, is actually equal to the negative of the function ft. So it is actually the negative of the function on the negative side. So if you can see from the picture here, the f of negative t, which is here negative a, is actually equal to the ft also here, but it is actually the negative side of it. So you need to change the position of the signal. So if you try to rotate this signal on the y-axis, you cannot map or reflect the signal onto the other side of the y-axis. Okay, so cosine function is an even function because it satisfies of f of negative t to ft, where the cos of negative t is equal to cos t. And the sine function is an odd function because it satisfies f of negative t is equal to negative ft, where sine of negative t is equal to the negative sine t. Alright, so important characteristic of even and odd function. Okay, this is when we want to find the total area under the even graph function. You see the area of positive area 1 and positive area 2, they have the same area, so area 1 is equal to area 2. Total area from negative a to a for an even function is actually equal to the integration from negative a to a of function t dt is equal to the area of 1 plus area of 2, or it is equivalent to the 2 times the area of 2 or area of 1. So characteristic of even function is the integration from negative a to a f t dt is equal to 2 integration from 0 to a f t dt. And the total area for the odd function graph is actually the integration from negative a to a of f t dt equal to area of 1 plus area of 2, because area of 1 is negative and area of 2 are positive, but they are in equal size. They will cancel each other and we will get 0. The characteristic of odd function is equal to the integration from negative a to a f t dt is equal to 0. Okay, so by learning this characteristic of even and odd function, you can simply calculate the Fourier series in some of cases in the most simpler way. So if you know that if the function is not even or odd function, what you can do is you find all the Fourier cosine series and Fourier sine series. You need to find what is the value of an is and also b sub n, a sub n and b sub n. And if you know that the function, so by learning the characteristic of the even and odd function, we can simplify the calculation of the Fourier series in some cases. For example, if you know that the function is not even or odd function. For example, in the question, they will give you the equation of the signal. So you need to plot, right? If you still remember, please refresh again on how to plot the signal. Okay, you just insert what is the value of x, then you will get the value of y. So you plot the signal of the function, and when you already plot the graph, you know that you can determine whether the signal is the even or odd function. So if you know that the function of ft is not even or odd function, what you need to do is that you know that your Fourier series cannot be simplified into Fourier cosine series or Fourier sine series alone. It need to be the combination of both of them. So you need to find all a naught, a sub n and also b sub n. Okay, so and then if you know that from the signal given to you, the function given to you, you know that the function is an even function. Okay, you already prove it by using the mathematical representation of the even function, and also from the shape of the graph. Also, you know that this is even function. You just forget about b sub n. You just need to find the value of a sub naught and also a sub n, because the calculation is a bit lengthy. So you can skip the time of finding the value of bn, because if you try to find the value, if you try to calculate also, you will get the value of bn is equal to 0. So just find the value of a naught and also an. And then if you know the signal as the function given to you is an odd function, Okay, you just need to find the value of Bn and substitute the value of Bn into this general equation of the Fourier series for the fs of t. Okay, so here, okay, you see that this is just the summary for modeling odd function. The odd function is equal to the f of negative x is equal to the negative of fx. Okay, and for even function, the f of negative x is equal to the fx. Okay, and then from this graph here, the function here, you need to remember p is equal to 2l, and then you have these three equations. So from here you know that this signal is an odd function. So what you need to do with odd function, you just need to find the value of Bn. So Bn is equal to 1 over L, and it is you need to perform the integration from negative L to L, and then fx sine n pi L dot x dx. Okay, so again you need to test your ability to know, to really know whether the function is fx is actually even or odd function, because in the exam, if the signal, the function is an even function, but you only find the Bn, the value of Bn, so you already lost all your mark there. So make sure you know exactly how to decide whether your function is the even or odd function. Okay, so example here, okay, from the shape you already know this is an odd function. Okay, and then you try to use the mathematical equation to definition of the odd and even function. So from here I know that it suits the first one, where the f of negative x is equal to negative fx. So this is an even function, and if you try to rotate the signal along the y-axis, you know that you cannot map the left side to the right side. So yes, this is an odd function. Okay, and then this one, y is equal to e to the power of negative x. So this is not even, this is also not an odd function. Okay, if you try to rotate, also cannot. Okay, this is not repeated actually, this is not periodic, so you cannot solve this using Fourier series expansion, Fourier series. Okay, so in summary, any periodic function, any function that is only periodic, that are repeating by itself and has a period, okay, it can be decomposed into infinite sinusoidal wave with various frequency. So fx is valid for any interval. So Fourier series arbitrary period of p is equal to 2l, where fx, you please remember fx is equal to a naught plus infinite summation of a n cos n wx plus b n s n wx, where the value of a naught is equal to this, a n equal to this, and b n equal to this. So from there, if you know that the function is an even function, what you need to do, find the value of a naught and find the value of a n. But then if you discover that your function is actually an odd function, sorry, so it is very simple, you just need to find the value of bn. So from the picture here, from the graph here, example of 10.3.1, is the signal above, is this signal is a periodic or non-periodic signal? So you can see that the signal is period, this signal repeats itself over finite period. Okay, because you can three dot there, 3 dot on the left, 3 dot on the right side. So this is a periodic signal. Okay, so the second one, if it is a periodic signal, identify its period, hence write its function. Okay, so you know how to write the function is fx plus np. Okay, So here, what is the value of p? P is starting, we can start from negative pi to pi. So we have this 1 pi and 2 pi. So we get the p is equal to 2 pi. The period is equal to 2 pi. So whenever you see this fx plus np, this equation, you know that this signal is a periodic signal. So for example here, find the Fourier series of the following signal. So fx is equal to negative k of x between negative pi and 0, okay, and k if x is equal to, is in between 0 to pi. The signal does not repeat itself. This is a non-periodic signal, and Fourier series cannot be applied to non-periodic signal. So it is not stated here the formula of the equation of fx is equal to fx plus np. It is not stated here, so it is non-periodic signal, and we cannot use Fourier series to the non-periodic signal. Okay, but then here the same thing, but it stated that fx equal to fx plus n 2 pi, where n is equal to 1, 2 until infinity. So this signal, we know that it repeats itself over a finite period. And from the graph also, we know that the period p is equal to 2 pi. So this is a periodic signal. Fourier series can be applied to the periodic signal. So fx, we can use the general equation of the Fourier series expansion of fx equal to a naught arbitrary constant plus the infinite summation of a n cos n wx plus b n sin n wx. So the arbitrary constant plus sinusoidal function. Okay, where a naught, a n and b n, you can use this formula to find the value of this coefficient. Okay, so now it is given to you fx plus n 2 pi, where n is equal to 1, 2 until infinity. So here you see that you can retrieve important parameter from only this, which is the period. P is equal to 2p. So from p you can get the value of L. So p is equal to 2L, so L is equal to pi. Alright, you divide the period into 2, and then frequency is actually 1 over p. So we get F is equal to 1 over 2 pi hertz. And the angular frequency 2 pi f, which can be converted into 2 pi p because f is equal to 1 over p, we can get the angular frequency of 1 radius per second. And then step 2, solve the equation, the coefficient. Because we know the shape of this signal is odd function. So odd function, we just only need to find what is the value of an. B sub n. Okay, so here we try to find the value of a naught. Okay, substitute. Okay, we start from here. Because just now I already told you, if you know already the shape of the signal or the function is an even function, you just need to find the value of bn. Because if you find the value of an, it is actually 0, so you don't waste your time. So here 1 over 2 pi over 2l is L is pi, and then integration from negative pi to pi. Okay, from negative pi to pi, from here to here, but then two different function here. One is negative k and one is k. Again, so you need to perform different. You need to separate the integration into two parts. Okay, so from negative pi to 0, we use the function negative k, plus from 0 to pi, the function is positive k. Okay, so what you need to do, just integrate. This k will become kx, then substitute 0 and negative pi, and then this 1 over 2 pi, you bring this out, and then k, integrate it become kx, you substitute pi to 0. At the end you will get the value of the integration is equal to 0. See, and then a indicate the average of the periodic signal, so a average of the periodic signal is equal to 0, so it is here. Step 3, find an. As I told you, if you find an when the function is even function, the odd function, the value of an is equal to 0. But then if you find the value of bn, you can get the output. So here, for example, find bn. Bn is equal to, from the formula, 1 over L integration from negative L to L f x sine nwx dx. So 1 over L is 1 pi integration from negative pi to pi, but then you have two functions, which is negative k and also k, and then separate it into two parts. You integrate k sine nx, you will get cos nx over negative n, and then substitute 0 to negative pi, and then plus 1 over pi, and then this k sine nx, if you integrate, you will get cos nx divided by negative n, and then try to solve it. You get 2k over n pi in the bracket 1 minus cos n pi, where n is equal to 1, 2, 3. So here you see that cos n pi, okay, cos n pi, okay, you can change this cos n pi into negative 1 to the power of n. So when the value of n is odd, if n is odd number, you will get negative 1. Okay, if n is even number, you will get 1. Okay, so 2k, whenever you have this negative cos n pi, you know that you can convert this into this, to negative 1 over n. Okay, so it becomes this, bn is equal to 2k over n pi, 1 minus negative 1 to the power of n. So but then for odd function, you will get the value of it as negative. Okay, but then if it is even, you will get the value of 1 as positive. So 1 minus 1 become 2. Okay, so it becomes 4k over n pi for odd n, but then here 1 minus 1 will become 0. So bn is equal to 0 for even, n is equal to even number. So we get b1 is equal to 4k over pi, b2 is equal to 0, b3 is equal to 4k over 3 pi, b4 is equal to 0, and so on. Next, the next step is you need to express the signal in the form of Fourier series. So your A node is 0, A sub n is 0, but B sub n is equal to, you have two answers for that, which is 4k over n pi for odd number, 0 for the n is equal to even number. Okay, so fx is equal to a node plus a1 cos x plus b1 sin x plus a2 cos 2x plus b2 sin x plus a3 cos 3x plus b sub 3 sin 3x plus ... And then you can get that fx is equal to, your a node is 0, and then okay, we start with the a1 cos x plus b1 sin x. So a1 is equal to 0, and then b1 sin x is equal to 4k and pi, alright, sin x, and then plus Okay, a2 cos 2x is equal to 0, and then b2 is equal to sine 3x. Okay, sorry, e3 cos 3x is equal to 0 plus b3 is equal to 0, and then also 0 0, and then we proceed with a4 cos 4x plus b4 sine 4x. Here a4 is equal to 0 because it is cosine, and then b4 is equal to 4k and pi sine 4x. Okay, the complicated square function with period p is equal to pi is a linear superposition result of multiple sine wave with odd frequencies. Okay, next, we need to convert this into the okay, this is done. Now I have one question here. A given function f(x) is even whenever f negative x is equal to f(x). True or false? So it is even when f of negative x is equal to f(x). So this is true. A given function f(x) is odd whenever f negative x is equal to negative f(x). This is also true. Okay, to tell whether the graph of the function below is even or odd function or neither. Okay, so here this is odd or even function. Try to rotate. This is even function. This is try to rotate on the y-axis. You cannot reflect it into the other side. So this is an odd function. Okay, determine algebraically if the function is even, odd, or neither. Okay, from here what you need to do, you need to plot a graph. Okay, plot a graph, and from there you know that it is even or odd function. Okay, this linearity property we will look at later. Okay, thank you for listening to the video, watching the video. Okay, we'll see you in the next class. Thank you. Assalamualaikum.